Okay, hi everybody. Sorry. I got a little ad in there. It's 101 and we have a nice crowd. Hi everybody. So it's wonderful to see you all on my very special day. It's my birthday. Notes for today in the chat. Thanks everybody. Thanks for joining us. I'm going to enjoy at some point today my cupcake birthday. The only business I think we have for today is that, again, we have our live notes. So if you haven't been to one of our Viz and Tells before, it's very casual. We're going to kind of all be in this document and you can add notes wherever you want and questions, and I'll be working with David today to present some material, but we want it to be a conversation. So feel free to share your own experiences with R and Python packages and ask questions. While one of us is presenting, the other one is likely to be monitoring chat as well as we can. But we'll try to include some breaks so people can unmute and can join in the conversation. Until then, we might go ahead and ask you to mute yourselves or help with the muting and unmuting if it becomes clear that somebody is having trouble. And David, any other thoughts?
There we go. Am I all right? No, I think that sounds great.
Yeah. And
happy birthday.
Thank you. And I'll highlight that in our notes document, we have a link to our May Viz and Tell. If you're on our mailing list, you may have gotten an announcement for that. And if you're not, I'll put the link in the chat. But our May Viz and Tell is going to be a different format. We are in the process of finalizing a design for an instructional module on ethics in data visualization. And we will be testing it out live. So we would like people to be in the audience and kind of act as our audience and give us some feedback. So that'll happen in May. Mailing list is here. This Viz and Tell is supported by the Visualizing the Future Symposium, which is an IMLS funded national forum on data visualization in libraries. And I'll include that link here as well.
Am I there now? Yeah.
And that's about it. I think.
Yeah, so the short of it is the
right.
logo.
I think I might go ahead and help mute everybody. And then I'm going to turn it over to David, who's going to have to unmute himself again. But I'll stop sharing. I'll be taking notes. I'll be watching chat. And let's get going.
Let's see. Hi, everyone. Let's see. Can I get back to the chat? Oh, I had one little thing I was going to send before. Oh, panic. Well, I will send, throughout this presentation, I have some GitHub gists that are basically the code for some of the visualizations that are in this presentation. I want to talk to you about some selected R packages for data visualization. This is very much an incomplete guide. I started off with a much longer, more convoluted title to kind of more accurately capture how specific this is, but then I thought my boss might join the presentation, so I decided to have something that sounded slightly more professional, hence selected packages. Part of why it's an incomplete guide is, here's a graph showing available CRAN packages by publish date, and you can see in 2000, 20, there are 5,000 new packages. Sure, some of these are updates and many of them are not necessarily about data visualization, but there are more packages on CRAN than anyone could keep up with. And then certainly tons of packages that are not on CRAN that will just perhaps be on GitHub. Here's a word cloud of some of the packages on CRAN since 2020. So that, to be sure, this sort of illustrates that they're not all about data visualization. Bayesian comes up at a much greater extent than, say, a visualization related word. But if you take words like plot, graph, design, shiny, spatial, and just look at the ones that have been published since 2020, you're getting several hundred new packages. So there's a lot out there, more than could possibly be covered. For the select ones that I'm covering today, I'm categorizing them into two very crude categories. The Tally O'Malley category, which is basically your ones that are more suited for data transformation before you actually make something visual, and then the Great Graph Contest. So those will be the ones that are actually doing the heavy lifting of doing the visualizing. So the first package I want to talk about today is the Magic package, which Magic probably is an unlikely choice to start with. It's an all-purpose image processing tool. It comes from, there's a library called Image Magic, and there's a STL for Image Magic, which allows it to be ported to other languages. So there's Image Magic for Python. There's a image, which I think is called Magic Pi. And then within the R environment, it's the STL, the package is called Magic. So you can do all kinds of crazy things with Magic. It can ingest any type of image you can possibly think of and do all sorts of transformations to those images. Here are a few examples from their vignette. The vignette is linked below, and once I figure out how to actually share a URL, I will send those at the very end. But the vignette is beautiful and sort of walks through all the interesting things you can do with the package. The picture shows a couple of examples. I got started with this package because I had a son who is like in his last year of preschool, and I wanted to make some dice worksheets to teach him addition. And so I drew some vector graphics in Inkscape. So like these dice you see on the left. And then I wanted to sort of lay them out in a worksheet. So I, made a worksheet. I think I made one in Inkscape. It took a couple hours and I thought, geez, this is kind of time inefficient. I'd like to produce, several worksheets and just be able to print them out as PDFs. So using the Magic library, you could import something like a SVG file. It then has abilities to lay out the different elements where you want them. And then you can, apply a randomization to then, just with this sort of built-in R functions to then randomize the dice and then export several PDFs at the end. So that's how I got started with the Magic package. In my work experience, I was recently trying to use Magic to help with some monthly infographics that I make at the library. So I make these infographics for the Board of Trustees on a monthly basis, and it takes a ton of time. There's some kind of feature that happens in the bottom section, but this top section was what I found really annoying to work on. I'd have to go visit several tables within our internal database in order to find these data points and then update it. Let me just skip a couple of slides ahead to kind of zoom in. Let's see. So it would take in things like active users, monthly digital users. I need to change these arrows. And so what I wanted to do is something like this, where it's basically finding those things and automatically laying them out on the document and then exporting them to PDF. So it's not actually doing the stuff in the bottom section. That's more custom stuff that I need to sort of tinker with over and over again. So I ended up writing some code in R. It works, but I ended up not implementing it in my process because it didn't save as much time as I thought. And so, yeah, I just wanted to show that as like something that I was trying. It failed in a way, but I'm now just going to move on to a couple other things that can be done with the package. So it's now time for Angela to get her birthday cake. So this is an example of using magic with a package called ggpattern. So the graphic itself is looking at the ratio of batter weight to room temperature water of the same volume. So anyone who's done home brewing will know about specific gravity. So this is the specific gravity of cake batters. So this is just taking a SVG input, and then which is handled by magic, and then ggpattern using this sort of ggplot2 style of grammar graphics will give you a nice little bar chart here using the input SVG files. ggpattern can do a lot of other types of visualizations too. So you can fill in maps with images or do some kind of density pattern. The one I made, this one in the bottom right-hand corner. These other ones are from their vignette, but the one I suddenly realized the one in the bottom corner I made with a package called GG Textures, which is basically a clone. It does the exact same thing. And in fact, on the ggpattern website, they happen to have a bar chart using flags that looks almost identical to this. I swear I didn't copy it. They're using completely different data, but I guess, it illustrates that this ggpattern is able to do very similar types of things. The next one I want to talk about is SF. So to me, SF is more of a Tally O'Malley type of package, not really about visualizing, but it does all the heavy lifting to allow you to do mapping visualization in R. So let me walk through very briefly the sorts of things you can do with it. So you can, with the SF package, you can take a shape file from the internet. It could be in a zip folder. You can unzip the shape file, load the shape file into R. You can do some kind of transformations on that shape file. So you could add polygons, for example, or edit your point data, maybe change the projection. And then you can then export the shape file for use in other environments. So if you were doing mapping in QGIS, for example, the SF package could be part of that process. I started using SF for, this is kind of a fairly early thing that I was using it for. So we're doing an analysis where we're trying to identify snow branches for our libraries in Seattle. And so we loaded up polygon data of our census tracts and then filled those with the number of branch staff that lived in those locations in order to find density of where staff live relative to our locations in order to predict which locations would be most likely to open in the event of snow or other types of emergencies where we're going to have some closures. And this was for the city wanted to be able for us to anticipate which locations we'd most likely be able to open, so that way they would have that information. More recently, though, I've been using the SF package to do geoencoding of library data. So we have everyone who has a library account, we will have some kind of address information for that person. But we want all of that information to be anonymized within our data warehouse. And so we take that address data and we encode it as, say, a census tract, and it will already exist as a zip code. And so with a sort of recent effort, what I've been doing is taking a shape file of parcel data, and that parcel data will include address data. So I'm using that as the match. And then taking a shape file with census tracts and sort of classifying which parcels are in which census tracts. This has kind of come up because now we have the 2020 census tract. And so there have been several divisions in Seattle with the 2020 census. So this is an example of a sort of current use. You can within R do fairly pretty maps using SF objects. So this is an example. This is from the vignettes page from a package called Maps SF. And so they have a lot of templates that will show, different things that you can do, like chloroplaths or a sort of classic looking map, sort of like the one in the center. It's not a package that I have a ton of experience in. It's only one that I recently discovered, but it might be a good option if you are looking to make something that is pretty and you're want to use something that's more of a template style. This is the Map SF is the successor of the cartography package, and cartography was kind of a big package for visualizing spatial objects within R. So my next example is using cartography. So this is a map that I made using SF, Magic, and cartography together. And so this is showing top electrical sources in 2020 by state. And so let me kind of walk through what's going on here, because there are a lot of packages that are playing together to make this map happen. And I'm not entirely convinced this is the best way to represent this data, but I just want to show you what can be done with cartography. So you start with you start with a shape file from the internet. So in this case, US states, and this is ingested by SF. So SF takes the shape file and gives you an SF object of states. I then get the data from the federal agency that keeps track of these things, which is the exact link is in the GitHub file. So there's a join that happens. And then the next step is to try to figure out which states are bordering each other that also share the same main source. And so this is really kind of a network analysis problem in order to figure out which ones border, but also have that same factor. And so by applying a couple lines of code in doing a network analysis, you end up with a map that looks kind of like this. So, so the SF is doing an intersect in order to join all those polygons to create a multi-polygon. And then finally, Magic is loading up these cartoonish drawings of energy sources that I made in Inkscape. And then finally, the cartography package creates raster bricks where it's cutting those cutesy icons into the shapes, those new polygon shapes, and putting them on the map. And then Magic handles adding these icons. You can sort of use Magic to sort of arbitrarily add anything to any R visualization. So if you make a visualization, then you want to annotate it with something like some kind of image, Magic can make that happen. Next, I'm going to talk about a package called TuneR. TuneR is a package for doing sound wave analysis and manipulation. There are a few other packages like it, including C-Wave. And there are a couple others that I'm not quite remembering right now. So this is more of it, although this is usually used as a analysis package, I'm putting it in a great graph category, and I'll show you why. But first, let me talk about like what a typical use of this package would be. So TuneR is used for sound classification. On the R blogger site, there's kind of an explanation of use of this package where basically you could take some kind of input sound. So in this case, that crow makes a caw noise. You record it as an MP3 or WAV file. There is some audio processing that happens within TuneR where the audio file is loaded into R. You can create a spectrogram for basically turning an audio problem into an image analysis problem. And then you can then break down that image into some kind of like convolutional neural network where you're taking different samples in order to predict what that sound is. And so the output is, oh, okay, we've predicted that that sound came from a crow. But I wanted to do something much more serious than this, which was I started by being a wannabe DJ with this package. So not only can you do analysis, but you can also, so it can take sounds in, but it can also export sounds. And so you can create electronic sounds with this library using some algebra. So here's an example of one of my earlier attempts where it's basically taking a sequence along from the number 0 to number 1 by a small fraction, and then putting that into a formula of x squared plus x, and that basically will give you a sort of half of a sound wave. And then so if you just take the inverse of that, it will then give you a complete sound wave. And so that's kind of the basics of how you could take some kind of numerical vector and turn it into something that represents a sound. And so as I was sort of experimenting with that, I was trying to be a wannabe DJ and made some really terrible sounds that sounded awful and will never see the light of day. But one of the things I realized is that, you can, with data, you can modulate, or you can apply data to those sounds and create some kind of modulation. And so that could be, you could modulate the pitch or the volume, or maybe some kind of time signature, like maybe how many times a sound chirps or whatever. And those sorts of things can represent data. And so, we often think of visualization as something that is visual, but I think audioization, or maybe even using other senses, is an interesting way of letting people experience data in a way that they maybe would not have otherwise experienced it. So, and another thing I was thinking about is maybe, as it's possible to detect nuances in data that you wouldn't necessarily see in a visual representation, like maybe a tiny bump on a graph is lost in a way where you might actually see that small bump when it was experienced in some other way, maybe as a vibration or as a sound wave or through some other kind of sensory experience other than the visual. And so I wanted to give an example of application of this library for audioization or audio visualization. So this one, this visual is called, or this audio is the pulse of COVID. And so it's cases as volume for the US and pitch as deaths. Each week is aggregated and represented by a second. The second will have the same sound for the whole second. So I'm going to play this. This goes on for a minute and 9 seconds to represent the 60 or so weeks since the CDC started keeping track of COVID data. This might fail terribly. The other day, I listened to, we had like an all staff meeting, and they played a YouTube video of somebody singing, and it was beautiful singing when you watch it from YouTube, but when you watch it over a Zoom call, it sounded really gross. So this might fail, but let's just try and see what happens. This is January. March. July. September. November. January. March. Just what the world needs, another COVID visualization. So some of these are unusual packages, or maybe ones that are maybe ones you wouldn't first think of when you're thinking of visualization packages in R. So I want to go to just a couple of my sort of favorite R packages really quickly to do a couple interesting, unusual tidbits about each one. So each of these will be kind of a lightning pitch showing something interesting you can do with these more common R packages. Oh dear, it looks like the leaflet got split on 2 lines. The first one is leaflet. On my screen, it does say leaflet, but it's showing it above the tile. So leaflet is a package for making interactive maps. Those maps can be exported to HTML and JavaScript. So this is an example of one that I use internally or maintain internally for staff that are doing planning. So there are different layers on here that are used for planning analysis. And the little tip that I wanted to give for this package is the make icon function. And so make icon allows you to take any kind of image input and represent it on the map. So this is the Visualizing the Future Symposia. And so I took our little icon here and represented it on the sort of home location of each of the organizers to sort of represent where those institutions are. I use it for something different. So for the planning map, I have an icon for our library locations, but I also have different icons to represent other things. So the other one you see, the little orange S, that one is Seattle Public Schools location. So it makes it easy when you have a bunch of pins on the map to sort of figure out what's what without having to click on everything. The next one that I want to talk about is dplyr. Dplyr is the most amazing package in R, and if you spend any time learning any package, this is the one you should learn. It is the Swiss Army knife of data manipulation. And there's so many tutorials out there that I didn't want to go into dplyr except for here in the lightning bit. And so the one little tip I want to share is using the row-wise function, which gives vectorization power to non-vectorized functions. So what does that mean? So let's say we have a data frame here. So this is months, January through April. And then we have some locations. So I work at the library. So central library, location A, branch B, and then some data about those locations. And so if you wanted to add another column to this data frame, and you wanted that column to be, say, the average, or maybe like the mean by of those three columns, you could mutate that data frame and add a mean. But when you apply mean with all three columns, it's going to take the mean of all three columns. So that's going to give you a single number and represent that number as a vector, which is probably not what you want. You want it by individual row. So if you just add row wise to that piped statement right before mutate, it then gives vectorization power to the mean function, which I think is kind of nifty. And then lastly, I mean, how can you talk about data visualization without talking about ggplot2? I'm not going to show any ggplot2 examples. The world is filled with way too many already that are more amazing than anything I could ever make. So why try? But what I will suggest, though, is visit. So my little tidbit tip is to go to the ggplot2 gallery on Tidyverse. And if you've been there before, go back again. It's updated, and some of the latest editions are very interesting. There's the cowplot library, I think, is a great one to check out. There are certainly many others. It's worth browsing to see what kind of interesting things that can be done to extend ggplot to additional functionality. So that's all for my portion. Thank you.
Excellent, David. That was really wonderful. And I did notice at least one question in the chat through that. I should have interrupted maybe to get it at the right time, but the question was, can we see the SPL chart somewhere on the SPL site? And I think it happened in the middle of kind of mapping examples.
This one.
Well, I think it was actually before you started talking about Tunar. So it might have been the SF Magic Cartography project that elicited that, but it might have been a little bit before that. I could defer to the question asker if they are still here. But in general, do you tend to post any of these visualizations publicly?
Yeah, so I've just pressed in the chat, I've just put all of the links to each of these visualizations that I created, which are almost exclusively on GitHub. So as gist files. And so the code is written in such a way that I've annotated everything. So you can sort of step through each of these and reproduce them or make them your own.
Yeah, there's a clarification from Graham that it's I think he was talking about your infographics, your monthly summary pages.
Oh yes, so those are publicly available. They are submitted to the Board of Trustees and appear in a really large PDF that the Board of Trustees receives every month. Where that lives on the website, I don't know, but it can be had. Mm-hmm. And I'm also happy to send you those as well, if you're interested.
We might be able to do some sleuthing while we're sitting around, but for now, any other questions? Okay, so Devin says, what does the SF library automatically work with GeoJSON? Yes. I forget whether that counts as a shapefile. Yes.
Yes.
Phew. Yeah, my understanding is SF is one of the more modern mapping options in R and is being kept up to date fairly well. It seems to be. Wonderful. Any other questions? So I guess I'll steal the share back from David, and that sets this up really well, because I'm going to talk a little bit less about interesting data processing and visualization libraries, of which there are many, and that was a really nice spread. And I'm going to instead talk a little bit more about layout than that. So what I'm especially excited about in R is how to get visualizations to play nicely with other content. So often I'm trying to intersperse visualizations and code with instructional material, or I'm trying to prepare a report on a particular data set or a process for stakeholders, or I'm even maybe trying to make a website to represent the work of my project. So I have prepared a GitHub repository here, which is linked in the notes, and I can share the notes again in chat. And let me try to pull up chat so I'm paying attention. Notes again, in case anybody's coming in and out. And what I've done on my little GitHub repository is I have made this into a website. So for those of you who are not as big on GitHub is a way to host your files and share them, but you can also serve websites from your repository. So I have a little link here to take you to the website for this little demonstration. And I've just included links to the packages that I want to highlight. Now you'll notice, unfortunately, that David and I are both R heavy rather than Python. So I'm going to try to zoom through my R packages quickly. And for those of you who are not R users and want to throw in Python equivalents in the chat or in the notes, that would be wonderful. But I will say that for most R packages, I tend to find that there are comparable things in Python. So it's usually not too hard to say, like, what is Python ggplot2 or something? And you can usually get some pretty good recommendations from the web, but we will have a little Python section at the end, and I'll lean heavily on my husband, Eric, who is in the audience today, who teaches visualization in Python. We have a house divided. So the first package I want to share is Plotly. Now this is a visualization package. It's something that is both a web app where you can just go to Plotly as its own website, and it is also a package you can use in either R or Python. So this is kind of both. For those of you who don't know Plotly already, I would highly recommend checking it out. It's got a lot of excellent features, a lot of different chart types. What I like about it for R and also for Python is that the charts that come out of Plotly, you write with code, but you get something interactive. So I love ggplot2. I teach ggplot2. It's a big part of my workflow. But ggplot2 is primarily a static visualization package. It's going to produce a visualization that's an image that you can really easily use in a report. You can paste it into a Word document or a PowerPoint, or, there are lots of different ways to use static visualizations, but sometimes you want to be able to click on stuff. And so Plotly is actually creating interactive visualizations here. You can see that I've embedded these visualizations in a website, and I've done that in my RStudio process. I've created an R Markdown file, and R Markdown files allow you to interweave text, like this introductory text at the top, with R code blocks. And the R code blocks will produce some kind of output usually. And in this case, this R code is producing a Plotly plot. That Plotly plot is HTML based, so it can really easily be embedded in a website, and it stays interactive. So it can be interactive when you're in R and you're programming in R and you want to explore your data and really click on things and look at patterns. But you can also export it as a web page that you share with people through just emailing them the file, or that you post on something like GitHub. And it has just really opened up a lot of avenues for me in sharing my results. So here's an example of a few Plotly plots. This has a ton of data in it. I don't remember how many rows, 30,000 or something. And the HTML is static, Graham. Yes, it's self-contained. So all the plots are sort of embedded in the single HTML file in this case. And it will work on your own machine and on somebody else's machine and just in the browser, but it will also work if you push it to a website. And in Plotly, you can zoom into things, you can hover over things, you can go back to the beginning, you can click on a line series to remove it. So it's got a lot of really handy features that are just built in, and you see I created this with very simple code. I will say line charts with multiple series are not my favorite thing to do in Plotly. You see I had to add traces, I had to add separate lines for each of the different colored series that I wanted to show up. But in general, the examples on the web are going to get you everywhere you need to go in Plotly. And yeah, and so Jennifer says you can export the plots as HTML widgets too. It doesn't have to remain in your knitted R markdown file. That's right. All of this code produces basically a self-contained HTML chunk that you can just pull into something else. So you don't even have to leave it in this context. So I really like Plotly, and Plotly is an example of a series of packages that produce these HTML widgets in R, and those are all really nice to include in website versions. And so another HTML widget is this package called DT, which stands for data table, and it produces interactive data tables. So if you want to be able to browse your data in a website interactively, you can do that here. So the default is nice. It's got sorting, it's got row color banding, it's got the ability to change the number of records that are showing at any one time. You can search in your data table, you can page through it. It's not going to be great for like millions and millions and millions of records, but it's going to work pretty well for even large tables. And just like with Plotly, these are all embedded in this HTML file. So this is standalone. You can hand it off very easily. So then you can also adjust properties in your data table. So this is something where you can change what data is going in. You can change what it looks like. You can change what features are showing up, like how many records in each page, and what you show in this menu, whether you're even showing this menu. You can also add column filters. So I really like the ability to sort of filter the data on the fly using these column-based filters. So that might be useful for your project. And if you have those, maybe you don't need this global search, so you can turn that off. There are just a lot of options. Data tables, kind of like Plotly, in fact, is actually something that has a lot of different versions, and R is just one of them. So if you learn data tables and you really like it, there's actually a JavaScript library and a bunch of other ways to use this kind of package for data display. So I really like those in my R Markdown documents, but wouldn't it be great if you could use both together? And there's another package called Crosstalk, and it will take things that have this HTML widget property and allow them to talk to each other. So I can actually have this Plotly plot, this data tables table, and these filters all interacting on the same shared data set. So I can take this date filter and I can filter down to a range of data points. I don't know how jerky that is over Zoom, but basically it's animating this kind of filter of the x-axis. I can specify which county I want in this data. So I can click on Mecklenburg, for example, and limit the data points just to that county. And it's one or more, so I could add more counties. And you can see that this table also updated with all of those changes. Now, technically, these charts and tables talk to each other too. So if I was really curious in this outlier, I could click on it and it would filter the data table down to that. And that works great. But unfortunately with Plotly, there's this weird thing where once you've selected a point, you can't unselect it and go back to the whole data set. So you can zoom in, you can individually select points, but to get it kind of back to the original, I tend to just refresh the website. So that's a little awkward, but other than that, I've been really happy with Crosstalk as an option. And Crosstalk works really well with Leaflet, which is another HTML widget package. So if you're in the mapping zone, you can make your little custom icons and everything, and you can show a data table next to it. It's all, I think, really powerful. So those are my kind of hacky ways of getting interactive elements into my reports out of our projects. Layout is sort of one. Can I compare? Okay, question in the chat. Can I compare Plotly DT Crosstalk to Shiny? This is my secret. I hate Shiny, and I'm trying to get as much away from Shiny as possible. So this was actually one of the things that I was so excited about with Crosstalk. I was like, how far can I get before I have to switch to Shiny? And so that actually leads me really nicely. And Matt's on this call, Matthew Siskas and we've been joking about how we have to have the like pro anti-Shiny debate sometime, because he uses Shiny a lot. He does a great job with it. But I am constantly trying to figure out how far I can get without using Shiny. And that's because Shiny is a package that allows you to create little web apps in R, very powerful. One, it's usually more powerful than I need. And two, it requires a special server to actually make use of the Shiny application element. So if I want to share a Shiny app with somebody, I have to post it to a special server for it to be able to run, or they have to have Shiny installed on their machine. And I just don't have access to a Shiny server, really. Like, I've kind of hacked my own one together, and you have something called shinyapps.io, which will allow you to share 5 apps at a time on the free account. But basically, I just want to see what I can do without having to go all the way to the level of Shiny, which is complicated code to write and hard to share. So all of this lets me stay in our Markdown land instead of going all the way to Shiny. So Flex Dashboard is this next package, and it actually produces something that looks fairly similar to a default Shiny app. I've got filters on the left. I've got elements on the right. I can lay them out in rows and columns. I could make tabs and everything, but Flex Dashboard is doing all this layout for me. It's still just an HTML document. And David mentions that Shiny apps also run slower than I would expect. So yeah, you're not going to have performance, especially on a free account. Shiny apps.io isn't giving you all the cores that you would want to have a really performant web app. I can't imagine that Crosstalk is like super performant, but I think there are cases where if what you need is really limited data exploration, you might get pretty far just by having interactive plots with Plotly, more detail showing up in your data table. This is a very toy example, so it doesn't have all the columns, but you could imagine having a much more detailed data set in the data table than you're showing in your Plotly. And you could have some documentation, you could have some checkbox filters that I'm not using here. So there's a lot of options, I think, to explore with these 3 or 4 packages. So really quickly on Flex Dashboard, this is a way of arranging things that to make it look a little bit more like a dashboard. It's not helping you connect the tools. It's not doing anything special to connect the plots together or the tables or anything. All of this is coming for free with Crosstalk. You don't have to go all the way up to Shiny to get filters, that kind of thing. But Flex Dashboard will allow you to make a really nice web page style layout instead of having something be kind of a scrolly single HTML page like you get with R Markdown. So I really like Flex Dashboard, and it's written in R Markdown, but it displays as a website like that when you compile it. The last package I wanted to share is called Learn R. And this is one where it does require Shiny, but it's worth it, I think, if what you're trying to do is create instructional material that really allows the learner to test out code. And so, for example, I created this Learn R lesson as part of a certification exam, and it runs on shinyapps.io. So it is using Shiny to create a mini R server in the background so that I can run R code live. And basically, if you click on the lesson, you can see I've got some of the same elements that you would see in a normal R Markdown. I've got text interspersed with R code chunks. And most of this content is not interactive. But when I get to an example, I actually can type in R code into this. I think I'm using empty cars in here, but anyway, basically I can type in a little chart, and I can say MPG class or something. I don't know. I don't remember what this is going to look like, but you can run it and it'll give you a custom error message. If you forgot something, it'll allow you to edit your code, et cetera, et cetera. So the Learn R package allows you as an instructor potentially to create a lesson. And it not only allows you to run example R code, but it will actually grade that R code and give you the ability to include a quiz here. So you can play with that, but I've really enjoyed potentially moving some of my workshops into these interactive learning experiences on the web. So we have all of 9 minutes to talk about Python. Sorry, I hope we don't have a ton of Python lovers in the audience, but hopefully we can transition a little bit over to that now. I'm checking the chat really quickly. Data tables for selection staff works great in HTML. The limitation you'll have to watch out for is that Crosstalk and Flex Dashboard are doing everything in JavaScript, no doubt. So you'll probably have some limitation of data size that you don't have the power of running R on a server. Yeah. I mean, even with Shiny, there are going to be packages that try to plot a lot of points to the web browser, and if it's not using Canvas, it can get just as slow. So I've definitely had Shiny apps that got bogged down because the performance of a visualization package I was using was not good, like an alluvial diagram with 1,000 lines. Well, that'll slow you up in Shiny too. So the fact that Plotly is able to handle 30,000 points in this line chart that I've showed, I've actually been pretty. I think Plotly is written well. Can DT allow for data entry? It can. You can actually do data entry in data tables. Now, if you do it in a website, it's not going to save anywhere. But if you do it in R, I think it'll update your data frame. I think it, at least I know the website does, the web version does, and I think the R version does too. So then I'm gonna ask Eric to unmute for a couple minutes, and we'll talk about Python packages. So there are a couple of packages that you'll see really commonly when you're doing data work in Python, and that includes pandas. And then we'll talk about a couple of other packages that are good, especially for visualization.
So yeah, so I think in Python, pandas is the main way that you would deal with a data frame. Sort of in R, it's high performance, it's got C code behind it. And so especially if you're already dealing with tabular data, spreadsheet type data in Python, if you want to visualize it quickly, one of the easiest ways to do it in some ways is to just use some built-in plotting that is within pandas. So it takes data sort of in a form like Excel would, where it wants each series to be in its own column. But there's a lot of things that you can do with just plotting directly from your pandas data frame. And so that's really handy to know how to do. I don't know what, I don't have control of your side. So there's also ways that you can do formatting. A lot of this is within Jupyter Notebooks. So this formatting stuff, so you can take any data frame or a pivot table that you create, and kind of like, again, in Excel, where you might want to do conditional formatting on the cells. So you can make kind of a heat map that has your data behind it, or you can make little bar charts in the columns. You want to be a little careful about this, because when you print it out inside of the notebook, it is not going to have the limitations. Usually when you print out a data frame and try to display it, it'll truncate it, so you're only displaying some values. If you try to do this visual formatting, it'll print out your whole data frame. So don't try it on a 30,000 row data frame. Do it on a pivot table or something like that. But there's a lot of ways you can do kind of faceted plots, line charts, bar charts right in pandas. Another one that's kind of nice to use is Seaborn. Seaborn is one of the packages that'll want tidy data in. And so I actually like that. It's easy to take a basic data set and do, it has a lot of different types of visualizations built in. You see there like a swarm plot for looking at a distribution of of one variable. You can do violin plots. It has a lot of statistical plots, and basically the place where I like it is if I'm doing a bunch of faceting with statistics. So there you see, I'm splitting 2 different bars for each day of the week. And this is some restaurant data of people that were smokers or non-smokers, how many tips did. So you facet the whole thing to smoker than non-smokers, to male, female, you put error bars. It has a lot of stuff built in, so you can do these complicated statistical plots really easily. The thing that I don't like as much is you have to kind of memorize all the different types of plots. Okay, is it a rel plot or a cat plot or a, so I get a little confused by that. But it can do some super fancy things like make a heat map and do hierarchical clustering on the rows and columns and put that dendrogram right next to the axes of your heat map. Like that would be a pain to build in a lot of other systems, and it has a lot of those built in. Now, if you're doing really large data, bokeh is the way to go. It's canvas-based plotting, and bokeh is made by Continuum, which does NumPy and has done like a lot of the core programming underneath for statistical computing within Python. And so they have ways that you can do visualization using bokeh itself or hvplot, which is a higher level interface to it. You can do it on very large data sets. You can do it out of memory data sets. You can do, it's all interactive. They've really made a very complete and amazing environment where there's hollow views, can take large scale data, and it'll do data culling as you zoom. So it'll only show you the number of points that you can actually see in the visualization. It's one of these things where you take like every person in New York City and you zoom in and in, like the kind of bokeh hollow views hvplot. That's the way to go with that. But I don't use it that much just because I don't deal with huge data that often. And so I have to kind of relearn it every time I use it. It also doesn't want tidy data, so that gets in my way a little bit, but you can use it in place of, use hvplot in place of the pandas built-in plotting, and it'll have interaction, everything all built in, has data tables that you can show. So it has some really nice things that they've built into it if your data is such that it works for that. One that I end up going to a lot because it thinks sort of like Tableau. So I use Tableau a lot for my everyday plotting. I teach Tableau. Altair is a module that uses Vega Lite in the background, which is basically D3. Vega Lite, so D3 is the JavaScript library. Vega is a declarative specification for D3, but it's very complicated and powerful. Vega Lite is a lightweight version of that that's less powerful and configurable, but it's much more manageable. And then they've built Altair and other language things on top of Vega Lite. And so with that, you take tidy data, it's easy to do faceting, filtering. Altair will do the aggregations itself, kind of like with Tableau. So I sort of, the way my brain thinks, especially having used Tableau for a long time, I sort of think in these declarative ways of specifying what my visualization should look like. It's not great for big data. It's not highly performant. So sometimes I want to do all my aggregations in pandas first before I feed it to Altair, but it's very flexible and powerful, and I kind of like using it. And it's interactive. You can put multiple charts together. You go to the very bottom, Angela, and you can see, swipe in there, and you can make these charts that interact with each other, and then they can embed all within an HTML file. And that can be just standalone, kind of like you're talking about with other things. So there, that's
Yay.
my fast version.
Thank you so much, Eric. Thanks for coming, everybody. Sorry if we didn't get your question, but we'll share the recording, and it was great to see everyone. Happy Earth Day.